All right. So hi, my name is Mark Bawtree. I'm the CEO at Sekai. Um, Basically, Sekai has been a digital twin consultancy group for a number of years now, over 6 years now, and we've recently pivoted the work that we're doing towards this cognitive infrastructure approach. And so I wanted to sort of get this opportunity, and thank you very much for this opportunity, to be able to just sort of do an education on what a cognitive infrastructure is for those that aren't so much aware, and how we are using it to really to basically one of the key aspects of connecting these digital twins. So I think a lot of people won't know what a cognitive infrastructure is. I think when I talk to most people, you get these blank faces of what's going on and how that's going in. A lot of people come to cognitive infrastructures in very different ways. And because this is, my background is very much on energy and sustainability, utilizing digital twins for that approach. So this is the way I'm going to present it to you guys as how I got into this world of ended up working with cognitive infrastructures and why, basically. So I think a lot of people ask the question, what is a digital twin? But now where do we use a digital twin? I think this is one of the key aspects here, some of the key aspects here. So as of early this year, there were 910 registered digital twin companies globally, and they're working on multiple different elements or industries and elements within those industries. So really trying to understand where all of these digital twins are doing and what they're doing. And I suppose, and it's quite, I myself, I was working with a digital twin in the built environment. So we were very much focused on smart buildings and smart building infrastructure and how to deal with that particular area. But the reason I bring these types of aspects up is because when we're talking to the clients, they really want to understand, they want to connect everything together. And so when we're focused with a digital twin, which is fantastic and a lot of work, and I think we all understand the benefits for all the different aspects of a digital twin for the different areas that they're being worked on. It's really kind of understanding that there's a lot more from the client point of view of what they need to see as part of the whole aspect of utilizing digital twins. And so even from, you can utilize digital twins within the design, the built, the used and maintained, through the processes and through the different aspects of the systems. And so what we have from a digital twin market point of view is really looking and seeing that there's all these different areas, from the parts twin, the product twin, the process twin. There's this huge growth that's happening, which is why we're all looking and interested in digital twins. But really understanding how can we utilize this from a client point of view, how can we utilize all of these digital twins to be able to provide the clients with a complete solution that helps them. So I wanted to just kind of jump back to this. This is a little old one, but I still quite like how it's being demonstrated. So why do we use digital twins? Really for looking at the clients at the end of the day. And so we're going from the step-by-step, the 5-step approach of being able to go from that initial information through to the physical object and digital object, to being able to bring that in with AI solutions, and then be able to then have those digital twins talking to each other, essentially. So that federation of the digital twins, bringing all the different multiple systems across, whether that's a process or whether it's a parts or whether it's an asset or service approach of those digital twins, is then being able to enable all of those systems to be able to talk to each other. And so this is where we kind of look at the whole macro approach and how I ended up looking at a cognitive infrastructure. So cognitive infrastructure is an intelligent layer that connects data, analytics, and human expertise. So it is very much human-centric as well. So enabling complex systems to learn, adapt, and be able to make better decisions. It turns siloed and fragmented data into insight-driven coordinated action across large-scale environments like energy industry, cities, and industries. So I'll run through quickly how we do that. So the key fundamental pain points right now, the way I'm going to run through this is basically going to run through some pain points and how a cognitive infrastructure can support these different aspects. So with a fundamental pain point where one physical asset, and a lot of people I know in this chat are around the building side, so really emphasizing the fact that one physical asset from different teams and different departments looking at that physical asset in a totally different way, how they utilize that data. But then a lot of the problems is the fact that this information is not being cross-referenced with each other. So these departments, these groups, these individuals, these organizations that are communicating with each other aren't really sharing the information across the departments and across the organizations as well. And what was interesting was earlier this year, an article came out that basically put a number to that. And that the fact is that according to this research, there's around $3.1 trillion annually lost in revenue and product, mostly around productivity, because people are spending around, on average, 12 hours a week just looking for that siloed information, that information that's floating around in different areas, different departments, and even within their own computers, as well, as I'm sure we've all experienced, trying to find that information within each of these areas. And so what we've done is we've created this cognitive infrastructure, which essentially is basically an intelligent layer that sits between the back-end information, whether that's any type of raw data or raw data sources, whether that's CAD or assets, ERP systems, literally in anything. And I think one of the key factors here is the fact that most of these systems have been designed without real time in mind. And so a lot of these companies have set up and they've been utilizing a lot of these systems for 10, 20, 30, even 40, 50 years. And so these systems aren't designed to really work in real-time scenarios. And so what we're doing is with an intelligent layer is being able to collect that data, federate that data from any of those different systems. And this could be any type of digital twin system as well, and be able to put that out into and with context, with purpose, with reasoning behind that, to then be able to utilize that for any further applications, and as a consequence also be able to build out digital twins. And the other aspect here is that we modularize that approach as well, so that we have this run engine called what we call the elastic knowledge graph. So we're utilizing ontologies with knowledge graphs, but we're bringing in a time series aspect to that. And then what we're doing is then modularizing it through these logic patterns where we have little services that can be utilized and run. And therefore that helps with the approach of utilizing that across multiple sites or multiple systems or multiple assets or multiple processes, and be able to build that up much quicker. And so what we can then see is then utilize that from that siloed information into this dynamic data structures, and then utilizing APIs to put that into any type of application. And this could be opened up into, for an example here, is green building certification. So being able to report out to green building certifications as an example. Okay, so just to run through, so these are some of the projects we've done in the past. So utilizing all of this asset information to be able to utilize whether it's physical assets or the real-time IoT monitoring, also looking at error codes or issues that are going on with the systems, but then also looking at each of the individual parts and components and understanding that. So we're collecting all these different information from edge systems, from supply chain systems, from finance, from all the different groups, to be able to collect and be able to demonstrate what that's all being done. And then talking about supply chain, starting to look at tying in the logistic aspects as well. So you can tie in to be able to track all the logistics elements. So you're starting to get all these different digital twin solutions and being able to connect this information through this intelligent layer, this cognitive infrastructure, and approach to this cognitive infrastructure. Okay. So what we've done, how we came about this, is we've been working with the OEMs, and a lot of the OEMs were looking to build digital twins for themselves, but we actually had to help them and work with them to be able to build these types of systems. And so what we did with people like Siemens, we were able to turn their for example, their gas turbines, it took 3 months to do the first gas turbine, took 2 hours to do the next one. And then they have a full, from that moment on, they then have a full digital twin to move forward with. And they're utilizing that digital twin for all the different purposes as they go forward. So training, installation, maintenance and tracking, supply chain, all the different works that go with that. And then we can also utilize that onto any different types of platforms and applications as done. And so really kind of bringing this home to the concept. So again, reminder, this is where we're sitting, is this layer, intelligent layer, to be able to bring all of that data down from the different systems, from data lakes, from different data warehouses, bring it with that context. And the reason why the contextual aspect is very important is so many projects are failing on their AIs right now. And obviously there's been some interesting articles that came out from Apple in June around how AIs are not really being able to be trusted or provide the information that's really needed to be able to utilize them so more effectively. And so with the invention of the MCP earlier this year, we were able to demonstrate that with this intelligent layer, this cognitive infrastructure, with the MCP, we could actually basically ring fence the data within the system and then be able to dramatically reduce the hallucinations across these systems. And then so how this really benefits the clients at the end of the day is that scalability of the different systems. So because of that logic pattern, the modular approach to this, we can scale out these systems very, very quickly. And then we can look at all the different systems and be able to tie those different systems to be able to put all these different connections together, these digital twins together. And then obviously what that does is bring a huge amount more insights by leveraging the AI on top of that to be able to take this and move this forward. So again, just a reminder of how we're approaching this from the data down to all the different applications, and obviously then onto human machine, making this human centric as well around using subject matter experts around these parts. Okay. And so what that does is really, and then on the application side, then you can utilize this for training, as I mentioned, training purposes. We can utilize that in VR or any type of media approach from iPads, PCs, and connecting that with the different documentation, whether it's PDF or through to real-time data or the visualization aspects here, as you're seeing with these different types of systems. So again, just a reminder, just conscious time, reminder of what our cognitive infrastructure. So what we're doing is we're bringing all of these different data sources and bringing this from these legacy systems or real-time systems, bringing it into this intelligent layer with contextual information, so you can utilize the AIs. So we're then helping to turn that fragmented data into insight-driven coordination action across large-scale environments. Okay. So I hope that's giving you a good insight into cognitive infrastructures.
So it looks like a powerful application of utilizing data. Are there tools from other organizations which would make your solution more effective? And if so, would this present issues for data sharing or compatibility?
Not at all. So to answer the second question first, no issues with data sharing compatibility. And yes, the concept here is the pivot that we've done is to move to focus just on the cognitive infrastructure, so that we are now starting to partner with multiple groups, consultancy groups, digital twin companies, visualization companies, software integrators, hardware integrators, to be able to enable that data, because the clients themselves have multiple systems across multiple suppliers. And from my experience working in digital twins, the client will never have one system for everything. And so it's very much, the concept here is very much connecting multiple systems to be able to then provide the clients with the different applications. And then on the application front as well, is that there will be multiple systems that will work to each of the different departments, each of the different individuals, and coming from sustainability, that's very important for us as well, to be able to move upstream and downstream and be able to share that data upstream and downstream as well.
Very good, thank you. Our second Go on,
Yeah.
sorry,
So
Mark,
the
please.
biggest challenge in implementing your solution, I'm going to keep. I talk about this a lot. I've spent 21 years in Asia. The mindset in Asia is very change-minded. They're constantly changing. They're constantly looking for improvements, looking for ideas. And the thing that I was in the US for a year last year. The thing that really struck me in places like the US was just the fact of change. They just refuse to change. Nothing. And so I think the biggest challenge for implementing a solution like this, and with digital twins in general, is this mindset of change, that they need to change. And it was actually quite interesting when I came back to the UK, was that the maturity of the conversation around change and digital twins was significantly better than pretty much anywhere else I'd heard, even in Asia, actually. So I was very, very excited to come back to the UK to hear all of this positivity around change.
Very good.
Which part do you find the easiest to sell in the market? The data solution, the digital twin, or the AI? Yes, I would say not the digital twin. It's really around I think for me, it's really working with the partners to be able to provide a total solution. So a lot of how we've approached the market is as a consortium. So we go in with multiple partners and provide a total solution to the clients. So the client has a certain pain point, but they still need a multitude of partners to be able to make that a success, basically.
Very good. And another question's come through.
Is there a particular sector which best fits the work you're doing? We are from an the company itself is from an industrial background. So we've done a lot of work in the industrial side. So a lot of the manufacturing. There's a huge amount of work and there's more acceptance in the manufacturing industry around this, and there's a lot more interest in utilizing digital twins and the technology around digital twins for the product itself, the supply chain of the materials to the product, then tracking the product to the site, training up the clients on the site, and then moving forward to maintaining and managing those as an individual digital twin. So at the moment, the most mature market I feel is still the manufacturing side, but there's a lot of more coming up in places like retail, and obviously energy would be the other big one as well. What's the difference between a knowledge graph and an elastic knowledge graph? A knowledge graph is static. An elastic knowledge graph is dynamic. And so you're actually being able to utilize that knowledge graph in real time. And some of the magic that we have is that we can actually, that knowledge graph will be self-healing in that process as well. So as more data comes in from different types of systems, it will be building relationships around that